This is a 13-inch ring machine for doing RTJs and standard raised face flanges, recessed flanges. And what we're going to do right now is we're going to put it up on to this part. And it's a smaller diameter machine than this hub, the OD of this flange. So we're going to put these little spacer blocks in here so it stands off of the part. At this point, we'll tighten down the 4 jaws on it. We'll tighten all 4 jaws down. We'll center the machine up, pull those shims out, and we'll square the machine to the face of the flange. And then we will assemble the machine completely by putting the drive motor on and the cross slide, and we will remachine the RTJ flange. What we're going to be doing is we're using a 13-inch ring machine to put an RTJ groove in from scratch. At this point, we'd already surfaced the face and laid blue out dye over the gasket surface, so I could measure and make a center mark for the center line of the ring groove. What we're going to do is we're going to take this tool bit and we are going to plunge into the groove where we're going to establish the groove down. It goes 3/8 deep, and we will start building the groove from that point. It's a blank as of right now. So at this point, we have established the first cut in the groove so that we can come back and start stepping out the outside edges to make the bottom width of the groove, which the bottom width on your part, your specific, according to you guys' blueprint, comes out being 3.348, which is 348 thou. We have an 1/8 inch in right now. We're going to go ahead and cut on each side of it, on the inside and the outside, to bring that number, because the first pass we went right down the middle. So I've already checked this when I first scratched it, but then I'll check it again, and I had already crunched my numbers, so I should be around 707 thou from the inside edge to from the inside of the bore of the flange to the inside edge of where our step's at, and we're at 710 thou, which leaves us ample room to continue cutting inward and outward. The depth of your groove is 375 thou, which is 3/8 of an inch. And what I got here is a blade mic, a depth mic. So I put my depth mic in here. I bring her down until she just touches. She gives me the measurement. These read backwards, so the 3 is vanished. 375 thou right on. So our groove depth is proper. Now I'm going to bring my tooling up and adjust it inward or outward, depending on whichever way. Doesn't matter, they both got to be done. So I'll screw. This is our cutting head. We'll bring our cutting head up. And it's really hard to see, but I will use this. This feeds it this way and that way, the cutting head. This goes up and down with it. That's how I control my depth. So now we have our tool set to the inside edge, so we can start making the groove wider to the inside, and then we will come back and do the outside. I'll start cutting, and then we'll come back with the finished product of the square groove in there before we put the angles on. We're going to stop right here and we're going to take a measurement from this corner that I just put in to the inside to make sure that we haven't gone too far. If we have, it's still regainable at this point because our angles will come in at a slope and still cut that area out. But I want to check before I go any further, and I'll be doing this throughout the whole process. When I put my caliper on here, I got 615 thou still, and just looking at square groove from the inside diameter here to where this square groove is going to be, I am allowed to have, it's going to end up at 595 thou. So I'm still a heavy 100 thou away. So I'll make this pass all the way down, move over, make another pass, then come back with a skim cut. Then I'll move to the outside edge here and do the same process, double checking my numbers as I go. Okay, so all we have here now is I have finished the groove. The groove is in. It does not have the two angles which create the sealing surface on the ring yet, but the groove is in place. It is to depth. What I have right here is the ball mic, what we call a ball mic, and it's just a transfer mic. So what we do with it is we'll put it down in the groove, put it in, touched off that outside edge, which is this outside edge, and the outside edge which is under the arm. I have my ball mic, it's set. I'm going to take it to a large caliper. I'm going to measure over the outside diameter of these balls. And I can see I'm at 6-inch, 861 thou. So this is a 3/8 by 3/8 square piece of tool steel that we have ground this chip breaker on and put relief on it so that it will go around and not, as they call it, heel out. Basically it'll go around and cut that groove in, and that's what we've accomplished with this right now, is we've cut the groove in and we have touched off the bottom, and it's flat across the bottom of the groove. Now when we go to the next step, we're going to put this tool bit in, which looks basically the same, but you can see it's ground back on this side. Maybe hard to see. And then this one will be for doing the inside angle, this side, and if you flip it over, we have another one that looks identical, except it's ground going the opposite side. The relief, you see, it's on this side, it's on the other side. Here is another style tool bit. This is actually a 1/2 inch thick instead of 3/8. It's for a different style machine which can do the same application. But this is what we call a smart level. It's a digital level. It reads the angle digitally to you within 1 decimal or 0.1 degree of an angle. So what I'm going to do is set it down on the part, and it's got an alternative 0 on it, so I can push that. So now this, it believes this flange face is now 0. Because I'm going to roll this cutting head so I can do the outside angle. So we now have it set at 67 degrees. I'm going to tighten up the screws that allow it to pivot, because we want to lock it into place. Here's the tool bit. We slide it into the tool holder, which is set at our 23-degree angle already. Just going to tighten it in place. Now by using this handle, we can crank this cutting head across to get to our outside step here, so we can start putting our angle on it to establish the actual sealing surface. Okay, so at this point we have finished the outside 23-degree angle for the ring to seat on to create its seal. So we're going to take the ball mics again. 40 or 37-inch 40 thou. I'm just going to sweep it. As it sweeps through there, it's going to find the high spot. Right there, we're at 7-inch 70 thou plus 7 thou, so 7-inch 77 thou, which is exactly the number we needed to hit. So that dimension is right on. Now we're going to go ahead. We're going to take the tool holder head, flip it the other direction, and just repeat the same process we did, just coming from the other direction on the inside of the ring. So we're going to put the 23-degree angle on this side now, which will complete the RTJ flange. What we've done here is we've resurfaced the RTJ flange now. We established a whole ring groove from scratch with the two angles, the two 23-degree angles on the inside and outside. What we showed you was resurfacing or building one from scratch. Now if you had a nick or a dent somewhere on the outside or on the inside sealing surface, it's not necessary to weld the whole thing up and resurface it like what we showed you. You can also, what we also can do is we will cut a little material off of the gasket surface itself, the face, which will give us material to put, so we're able to cut out of the bottom and the angles, which will reestablish the whole ring back to stock, and it'll just thin the flange lightly. A lot of companies go that route when they do RTJs.